Live from the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, welcome to NASA's New Horizons Countdown to Pluto. I'm Mike Buckley from APL Communications and Public Affairs, joined once again by my colleague Dwayne Brown from NASA's Office of Communications. And Dwayne, we are on a ride.
It's getting close. Mike, let me tell you something. This is what I call an ST mission. What's ST? Words that end in ST. Words like fastest, most, best, farthest. This historic mission is one of many firsts. Let's take a look at some examples of those ST words. The fastest spacecraft ever launched, the farthest destination ever explored, first mission to Pluto and a binary planet system, first mission in NASA's New Frontiers program. And Mike, I have to tell you, the media and the public love ST missions. This is a gold mine. They're loving it.
Oh, and you can see it. You can see it in the attention and the coverage is getting online, every place you look. Great. You know, because we're counting down to New Horizons' historic flyby of the Pluto system. And today we're just 2 days away and just over 1 million miles from Pluto. And when New Horizons gets there, as you'd expect, our spacecraft is in for a very busy day.
So July 14th is going to be really exciting. We have observations planned with our whole suite of instruments.
Things really begin to heat up at about 3 hours before closest approach.
As we're flying by, if my hand is Pluto, the spacecraft will fly by and it'll scan the LISA instrument across the surface of Pluto to build up a spectral image of what the surface looks like.
Then as we get around toward Pluto's terminator, we take our very long, high-resolution scans in black and white, which means that we can use the very wide-field MVIC and at the same time use the narrow-field LORI. So we get 5,000 pixels across Pluto, about half a kilometer resolution at closest approach. At the same time, we have this very skinny inset of the LORI field of view at only about 100 meters per pixel. So we take our LORI images one after the other, these overlapping images. So what it looks like is this big plate of Pluto and the skinny little noodle of LORI running across the middle. At this point, we are, for the first time in humanity's history, behind Pluto, taking pictures back on the far side.
The ALICE instrument will be doing a solar occultation, which is watching the sun set behind Pluto. The Deep Space Network will be transmitting a signal, and that signal will be picked up by the antenna, and it'll be changed by the atmosphere of Pluto that it has to go through. And that's how we probe Pluto's atmosphere, the pressure and temperature right near the surface. July 14th is the apex of what we've been working for. We launched more than 9 years ago, and ever since then we've been trying to shepherd the spacecraft safely across the solar system.
As spacecraft goes, New Horizons is a very small team, but still we've been working on this for over a decade, and you add it all up, and it's about 2.5 million work hours to get ourselves to Pluto.
We can't wait to get to Pluto and to July 14th and see what the surface looks like. We're ready to go, and it's showtime.
So coming to us from the remote set outside Mission Operations at the Applied Physics Lab is New Horizons Mission Operations Manager Alice Bowman. Alice, can you and the team start to feel how close to Pluto we are?
Oh, Mike, it's just wonderful. We are just simply amazed at the data that the spacecraft is returning.
Let's just ask first question, how is New Horizons?
Well, we've been monitoring all the subsystems and the instruments, and everything is healthy. We're ready for closest approach science.
So let's take a look inside the Mission Operations Center at APL and the activity that's happening there. Now, Alice, if you could maybe look forward for a couple of days and let us know on the morning of the 14th, when New Horizons is flying past Pluto, what will this room look like?
Well, Mike, as you know, the spacecraft can't be communicating with Earth at the same time that it's taking science. But as you also know, we have an instrument on board the spacecraft that requires an uplink signal from the Earth. So if you were to look in the Mission Operations Center between maybe 4:30 and 6:30 a.m. Eastern Time, you would see that we would have our flight controllers and members of the REX team configuring the antennas. We actually will be up with 7 of the Deep Space Network antennas simultaneously, and you will see them configuring those antennas and sending the uplink signal to the spacecraft. And then about 4.5 hours later, when that signal arrives to the spacecraft, that's when the observation will occur.
Alice, this is Dwayne. That's the morning event. Folks have to remember that this is a 2-part affair. There's some things happening on the evening of July 14th. Tell us about that.
Yes, the evening is going to be pretty exciting. We will have a slight break in the science observations on board the spacecraft, and the spacecraft will turn and point to Earth and send 15 minutes of telemetry towards Earth. We'll receive that telemetry about 4.5 hours later, which will be at about a little bit before 9 p.m. Eastern Time, 8:53 to be exact. In the MOC, we'll have subsystem engineers anxiously awaiting that data. We'll be up with Madrid Station, and we'll lock onto that signal, and our subsystem engineers will be able to evaluate the health of the spacecraft and hopefully tell how much data has been recorded to the recorders.
Well, Alice, I know it's a lot of intensity and a lot of excitement. How do you relax, sort of just to settle down before you really get into all of the engineering and all of the mission ops? How do you do that?
Well, many of us will be taking maybe cat naps in our offices, but we're all so excited to be part of this mission, to see that data for the first time. It's going to be hard for us to relax until after that closest approach flyby telemetry.
Alice, I guess at least until then, you've got some things to keep you busy. What's happening with the operations team over the next day or two?
Yes, in fact, this morning we got some optical navigation data down from the spacecraft. We were up with the Goldstone antennas. That data is now being processed by the navigation, guidance and control, and science operations team. About 1:30 this afternoon, we'll get another and final set of optical navigation data, and this is data that's going to be used to determine whether or not we need to do a slight time adjustment to those science observations. Additionally, we're going to be bringing down more science data, and also in the evening we'll be doing an uplink to the REX instrument.
Okay, sounds like a busy enough day. Leading up to this. Thanks, Alice.
Thanks.
Now, how much time would it take to find your Pluto time? Now, if you've got a minute, we have an answer.
Pluto is super far away, but it's way brighter up there than you'd think. This is Pluto in a minute. Pluto rotates on its axis just like the Earth does, which means that Pluto has days just like the Earth. However, they are slightly longer days. Each day on Pluto lasts for 6.4 Earth days, which is about 153 hours. And just like on Earth, the length of the days on Pluto vary depending on your latitude, that is, how close to one of the poles you are. Pluto's axis is actually tilted. From New Horizons' perspective and all the pictures that you're seeing, the North Pole is actually tilted slightly towards the spacecraft. You can see it about 1/3 or 1/4 of the way down in all of these images. That means some spots on Pluto have longer days or even continuous days, while other spots have very short days or no day at all. And these constant light and constant dark areas change depending on where Pluto is in its orbit. And even though Pluto is 3 billion miles from the Earth, it's a lot brighter at mid-Pluto day than you might think. If you want to find out just how bright it is, you can do that. Go to solarsystem.nasa.gov/Pluto time. From there, you can enter where you live, and it will tell you at your local time what the equivalent brightness is as noon on Pluto. So definitely go check out what Pluto time is going to look like in your time zone. Set an alarm on your phone, and when it goes off, hop outside, take a selfie, and tweet it using the hashtag PlutoTime and PlutoFlyby. And of course, tweet your questions with those hashtags as well. For more news on Pluto, be sure to check out the New Horizons websites, and be sure to come back tomorrow for more Pluto in a minute.
Joining us from the remote set outside the science team working area is Alan Stern, the New Horizons principal investigator from Southwest Research Institute. You know, and Alan, I'd welcome you to the countdown, but I think you've been in the countdown for quite some time.
Hi, Mike. Good morning. Yeah, we've been working on this for a long time, and it's finally going to pay off.
You know, after months as a dot in the camera's lens, Pluto has slowly started to evolve into a real world, and especially over the last couple of weeks, really get into a real world with lots of detail. And I just wonder if, from your point of view, what's that been like to watch this planet evolve in front of your eyes?
Well, it's been fabulous, and I think I speak for the whole science team. You know, after working on this so long and having images that were so crude before we got on the spot, that were just a few pixels across, made from Earth or Earth orbit, and to see that double and then quadruple, and then a factor of 10. And we've had about a total of a factor of 30 improvement. And now when you look at an image of Pluto, you see a real planet there. You see a complex world that just begs for exploration. And yet, we're going to do 100 times better than that with the images made on Tuesday. In fact, the images made will have 10,000 times as many pixels in each pixel as we see now. How's that?
I'm blown away. Wow.
Alan, well, this leads right into my question. You have worked on this for years, the planning, all of the work. How does it feel to be this close?
Hey, Dwayne. Well, it feels fantastic. And I think I speak for the whole team. People have poured their lives, big portions of their careers, nights and weekends, very long numbers of hours, great devotion. We only have one spacecraft. We have to get this right. And now we're on Pluto's doorstep. And it's just thrilling to all of us. And I can't imagine what it'll be like the day after tomorrow when we actually get there and accomplish this.
Well, Alan, I don't need to tell you that the whole world's watching and they are excited. Take us into the minds of the team. Obviously, they're focused, but what are they thinking? What's in their minds? What's going through their heads right now?
Well, a lot of things are going through people's heads, actually. You know, there's this electric atmosphere that I talk about. People are thrilled. They're working long hours. They're running on adrenaline. I see people in the gym in the morning. They say, I got 4 hours sleep. I feel like $1 million. And, you know, people are happy because they know their spacecraft is working well. They know their instruments are working well. They see data coming down. And Pluto is not disappointing, and neither is the satellite system. So the feeling around here is one of real joy and elation. It's a very human experience for our team that waited so long anticipating this approach to this faraway frontier, and now we're there.
Alan, are you starting to see things that either, I don't know, surprises or things that are starting to excite you? When we talk about the details we've seen in just the pictures of Pluto and in Charon, some things that have really got you excited for the next coming days.
Yeah, we're seeing real complexity on Pluto's surface. We're seeing evidence of a very complicated history that we can read through the geology and through the other techniques like composition and thermal mapping, topography that we'll be able to do. And when we look at the other half of that double planet, when we look at Charon, it's a rising star. It turns out to be super interesting, perhaps a lot more interesting than anybody guessed. And so we're going to get closer. We're going to be able to see them in even more detail, throw new kinds of data sets like atmospheric data on top of this, thermal data on top of this, the radio science data on top of this. It's just getting better and better.
If you can give us an idea then, just really what are we in for over the next couple of days? I mean, whether it's just the pictures or the atmosphere around here, what are we in for?
Yeah, well, as I said, we're going to really blanket the planet and blanket the satellites with imagery and with imaging spectroscopy so that at every pixel we have a composition spectrum. And then we're going to start detecting the atmosphere and be able to determine its temperature and its pressure, to measure its composition as a function of altitude, and do many more things, including look for satellites and rings. Now, I have a graphic here that I'd like to show. It shows what our best resolution on Pluto would be like if instead we were flying over the Earth at the same altitude and looking down on New York City. And if we were to do that, you can see in that graphic, which we've taken a satellite image of the Earth, pixelated it to about our best resolution. And you can see Manhattan there between the Hudson River on the left and the East River on the right. You can easily pick out Central Park. You can pick out the ponds in Central Park. It's just fantastic. You can count the wharfs on the Hudson. You can see runways up at the major airports. That's the kind of resolution that we're going to have. Today, our best pixels, today on Sunday, the the 12th, are about the size of Manhattan. They're going to get all the way down to the wharfs in Central Park. The wharfs on the Hudson and the ponds in Central Park.
I mean, and just the atmosphere out here, we can feel it. I mean, even just out here and outside our studio, you know, people are starting to come in and get excited for this. I mean, just think about all the excitement and what's going to be happening here over the next couple of days.
It's pretty amazing. We have, I understand, hundreds of media coming, and by my count, from all around the world, which shows there's a hunger for exploration. People love the kind of things NASA does. They're inspired by it. I believe every continent on the Earth is represented except Antarctica, and I don't think Antarctica has any media. It's just amazing.
One word, Alan, wow.
All right,
Wow,
Alan,
Dwayne.
thanks.
You bet.
You know, NASA missions in the solar system and beyond not only return unprecedented science, they inspire the next generation of explorers. And here's one prime example. New Horizons is one mission that is carrying a student-built instrument, Student Dust Encounter. Let's hear from someone on that team who can't wait to see Pluto up close.
My name is Jamie Zalay, and I'm the lead grad student on the Student Dust Counter aboard New Horizons. The Student Dust Counter is the only interplanetary instrument that's been made and operated by students. When SDC was being built, there were a lot of students, and the largest up to about 25 that were involved with this instrument. And they had jobs that ranged anywhere from software engineering to mechanical to thermal design. So what the Student Dust Counter does is it's a micrometeoroid detector. There's tiny little bits of material out throughout the solar system, and the Student Dust Counter all along the way that New Horizons is taking to get to Pluto is detecting little impacts of these tiny little grains. And what this does is help us understand the distribution of this debris disk throughout our solar system. And all of the sensors, except 2 of them, are facing the RAM direction, or they're roughly on the windshield of New Horizons. The little tiny pieces of dust are about a fraction of the size of a human hair, while the instrument is about the size of the pizza box, and so there's no danger of it running out of space to collect hits. So the Student Dust Counter was made by students, but it had to fulfill all the requirements that NASA needs to be on a mission, and that means that it is a real instrument and it is doing real science aboard New Horizons, just like every other instrument. So far, as of October 2010, in fact, it became the farthest reaching dust detector, student-built or not. And so every day it's continuing to break that record and collect new data. We've already been able to refine our models of the solar system dust distribution because of this instrument. This is an incredible experience. There's no other instrument like it, and students have been so excited to get their hands on this. I know personally I was. This is an incredibly unique experience for a grad student to be able to operate and pretty much run the show for an instrument that's aboard a NASA mission. And a lot of the students that have worked on this have gone on to really great careers in space science. My name's Jamie Zalay, and I'm a Plutophile because I can't wait to learn about a whole new class of objects in the solar system.
Now, just as Amy showed you Pluto time on Pluto, why don't we take a look at some of your views of Pluto time here on Earth?
And keep sending those images in, and don't forget, you can get the latest images, science findings, and mission updates right here on NASA television over the next several days. And join the conversation via Twitter, Facebook, and other social media platforms talking about the historic July 14th flyby. And yes, send in your questions at #PlutoFlyby. And again, all the mission information and images are available online at www.nasa.gov/New Horizons.
And that's the latest from NASA's New Horizons mission on Pluto's doorstep. 2 days and just over 1 million miles to go until New Horizons makes exploration history. Now, our own countdown to Pluto is wound down. From here out, stay tuned to NASA TV and the web for special coverage of this week's Pluto flyby activities. You ready for the ride?
I'm ready.
All right. I'm Mike Buckley.
I'm Dwayne Brown.
And for the New Horizons team, thanks for watching.